Friends, this is Rahul Prasad here and you are welcome to my channel, that is Concepts by Rahul Prasad. If you are a medical professional currently dealing with the cardiology, or if you are a pharmaceutical sales and marketing professional dealing with cardio range of brands, then this video is just right for you. So please watch till the end. Today my topic is about how do lipoproteins transport or carries the lipids from one point of the body to another. So the entire lipid transport is divided into three stages. The first stage is the transport of lipids via chylomicrons, that is the exogenous source of lipids. The second stage is the transport of lipids via VLDL, that is very low density lipoproteins, that is the endogenous source of lipids. And the third stage is the reverse lipid transport with the help of HDL cholesterol. Now let's begin with the first stage of lipid transport, that is the transport of lipids of exogenous origin. When the dietary triglycerides enters the gut, it is broken down into fatty acids and glycerol. Now these fatty acids and glycerols enters the enterocytes where they are resynthesized and packed into chylomicrons. Now these chylomicrons have apolipoprotein B, apolipoprotein C2, C3 and apolipoprotein E. These chylomicrons, now it is ready to enter the circulation and they are encountered by an enzyme called as the lipoprotein lipase, which is primarily responsible for the hydrolysis of triglycerides from these chylomicrons, and again a large amount of free fatty acids are released into the circulation. Enzyme lipoprotein lipase is present on the capillary endothelial surfaces of adipose tissues, skeletal muscles and the cardiac muscles. These skeletal muscles are very effective in trapping or uptaking these fatty acids, and wherein they are immediately oxidized to give us the energy. On the contrary, about 2/3 of the fatty acids are stored in the adipose tissues. They pick up the fatty acids from the circulation and store it in the form of triglycerides for the future use. Whereas the rest amount of fatty acids are bound to the plasma albumin and they are circulated in the human bloodstream as NEFA, that is non-esterified fatty acids. Ultimately, the enzyme lipoprotein lipase helps in the hydrolysis of large amount of triglyceride which is stored inside the chylomicrons, and ultimately the chylomicrons get devoid of the triglycerides and they become very poor in the triglycerides, which is called as the chylomicron remnants. These chylomicron remnants are ultimately removed at the level of liver by cell surface proteoglycans and also as the LDL receptor mediated mechanisms by virtue of the apolipoprotein E receptors present on the surface of the liver. Completes the first stage of the lipid transport. Before moving on to the next stage of the lipid transport, let me tell you one important thing, that fatty acid trapping is one of the critical processes and there are two major pathophysiological determinants which are solely responsible. The first is insulin and the second is the acylation stimulating protein. Now this acylation stimulating protein is basically the breakdown product of the proteins which are secreted by the adipocytes. It consists of adipsin, factor B and the third component of the complement C3. Both insulin and ASP play a critical role in regulating fatty acid uptake and released by the adipocytes. If in case the fatty acid trapping by the adipose tissues goes down, then there will be increased number of free fatty acids in the circulation. So this increased free fatty acid will create a fatty acid flux to the liver, wherein these fatty acids are converted into triglycerides and they are now synthesized or structured into a lipoprotein which is called as VLDL, that is very low density lipoprotein, which consists of apolipoprotein E as well as apolipoprotein B100. With the VLDL particles actually entering into the circulation, this starts the second stage of the lipid transport, wherein the liver is primarily responsible for the transport of lipids and VLDL particles are the lipoproteins which majorly consist of the triglycerides as well as cholesterol. These VLDL particles, after encountering an enzyme called as the lipoprotein lipase, which is present at the surface of the capillary endothelial cells of the adipose tissues, skeletal muscles as well as the cardiac muscles. So these are mainly utilized by them, and further the VLDL particles are converted into intermediate density lipoproteins and IDL is also converted into LDL particles which majorly consist of the cholesterol. Now this LDL cholesterol are primarily responsible to carry or transport the cholesterol to all the peripheral cells of my body. When this cells utilizes the cholesterol or picks up the cholesterol, it is majorly used for the control of the signaling. It also helps in the membrane function. It also helps in to give the structural integrity to the cell membranes, to the cells, and also act as the thermal insulators to the cell. Besides this cholesterol is also used for the formation of the steroid hormones, corticosteroids, sex hormones, etc. So the LDL cholesterols are basically the remnants of VLDL cholesterol, and the LDL cholesterols transports the cholesterol from the liver to all the peripheral tissues of the body. But what about the cholesterol which is not being utilized by the peripheral cells? Here comes the role of HDL cholesterol and the mechanism called as the reverse cholesterol transport. The HDL cholesterol picks up the cholesterol which is not being utilized by the peripheral cells via ATP binding cassette transporter type 1, and there is an enzyme which is called as the LCAT, that is lecithin cholesterol acyl transferase, which starts converting the free cholesterol into the cholesterol esters. There is a protein or the receptor present at the surface of the liver which is called as the hepatic scavenger receptor type 1, which helps the HDL cholesterol to carry all the cholesterol or the transport of the cholesterol or the cholesterol esters contained inside the HDL cholesterol back to the liver, wherein they are catabolized and they are without catabolizing the HDL cholesterol. Alternatively, there is a protein or an enzyme which is called as the CETP, that is cholesterol ester transfer protein, by virtue of which the VLDL exchanges its triglycerides in return to the cholesterol or the cholesterol esters present inside the HDL cholesterol. And HDL cholesterols are definitely the one of the best cholesterols which is having a positive impact on the human blood. It's the lipid transport. Thanks for watching the video. Have a great day.